Welcome back, students. Today, in this session, we are going to solve some of the questions given in the exercise from chapter 14, Statistics. So, starting from exercise 14.2, question number 1. Question number 1 says, the blood groups of 30 students of class 8 are recorded as follows. We represent this data in the form of a frequency distribution table, which is the most common and which is the rarest blood group among these students. So here we are asked to form a frequency distribution table of the given blood groups of 30 students of class 8. So here you can see that if you observe those given blood groups, you can see that 9 students have their blood group as A, and 6 students as B, and 3 students as AB, and 12 as O. Then 12 students have blood group O. So you can make two columns like this, blood group and number of students, and this blood group A, B, AB, O, and in the blood group A you have 9 students, blood group B has 6 students, AB has 3 students, and blood group O has 12 students. So in this way you can prepare your frequency distribution table. And now to the second part of the equations. So the answer to the second part of the equation will be, so you can clearly observe that the most common blood group and the rarest blood group among these students is O and AB respectively, as 12 maximum number of the students have their blood group as O, and 3 minimum number of students have their blood group as AB. As from this data you can see that the maximum number here is 12. So 12 is belongs to the blood group O, and the minimum number 3 belongs to the blood group AB. So the rarest blood group will be AB and the most common blood group will be O. So these are the frequency. So checking the frequency, you can easily tell which is the rarest and which is the most common blood group. Next, question number 2. The question number 2 says the distance in kilometer of 40 engineers from their residence to their place of work were found as follows. So construct a group frequency distribution table with class size 5 for the data given above, taking the first interval as 0 to 5, in which 5 is not included. What main features do you observe from this tabular presentation? So here we are going to construct a group frequency distribution table. In the earlier question number 1, we have construct a frequency distribution table. So in this particular question we are going to construct a group frequency distribution table. So the class size is also mentioned as to take the class size as 5, taking the interval starting from 0 to 5. So the class size will be like 0 to 5, 5 to 10, 10 to 15, like this, in which the upper limit of the class is not included. So by convention, if suppose this 5 here, this 5 will be included in the class in the next class 5 to 10, and it will not be included in the 0 to 5. It will not be included in the class 0 to 5. So you can construct your group frequency distribution table by making two columns, three columns like this, distance in kilometer. For your for you to make it easy, let us include this daily mark and number of engineers. So in this column, distance in kilometer, you are going to make your class interval 0 to 5, 5 to 10, 10 to 15, and up to 30 to 35 according to the given data. So if you observe the given data, you can see in between 0 to 5 there are 5 frequency, that is the number of engineers is 5 frequency. The distance there is 5 engineers, their distance from their workplaces, it lies between 0 to 5. And in the class size 5 to 10, in the class interval 5 to 10, there is 11 engineers, and in 10 to 15 there is also 11 engineers. This will be our frequency. And 15 to 20 there will be 9 frequencies, and 20 to 25 there is 1, 25 to 31, and 30 to 35 2. So in total 40. Let us see again for you to clear this. Here 0 to 5, let us find the distance which is between 0 to 5. So we cannot include 5. 5 will be included in the next interval, 5 to 10. So here it is 1, 2, 3, 4, and then 5. So between 0 to 5 there are 5 number of engineers which their distance is between 0 to 5. Likewise, you can count those numbers between 5 to 10, excluding the number 10. 10 will be included in the next class interval, likewise. So you can prepare your frequency distribution table like this. And for the second part of the question, that is, your answer will be, it can be observed that there are few engineers whose homes are not more than or equal to 20-kilometer distance from their workplace. So most of the engineers have their workplace up to 15-kilometer distance from their homes. Next, exercise 14.2, question number 9. A company manufactures cars batteries on a particular type. The lives in years of 40 such batteries were recorded as. So these are the lives of the 40 batteries in years. So some batteries last 2.6 years, some last 3 years, and 3.7 years. Likewise, these are the given data of the lives of 40 batteries. And you are asked to construct a group frequency distribution table for this data using class intervals of size 0.5, starting from the intervals 2 to 2.5. So you are instructed to form a construct a group frequency distribution table using class intervals or class size of 0.5, starting the intervals from 2 to 2.5. So you can construct your group frequency distribution table by constructing two columns. By making two columns, in the first column you can write it as lives of batteries in hours and number of batteries here. So in the column lives of batteries, you are going to start your class interval from 2 to 2.5. Next will be 2.5 to 3, 3 to 3.5. Likewise, up to the last class interval will be 4.5 to 5, according to the given data. Now let us see how many frequencies are there between the class interval 2 to 2.5. So we can check the given data. So here we are going to see those numbers lying between 2 to 2.5. So here one is there, 2.2, another 2.3, so 2 and 2.5 will not be included here, it will be included in the next interval. And that is all. So only two frequencies are there between the class interval 2.2 to 2.5. Likewise, you can find the frequencies of the remaining class interval, and you can construct the your group frequency distribution table like this. Next, exercise 14.3, question number 2. The following data on the number of girls to the nearest 10 per thousand boys in different sections of Indian society is given. So here is the section: scheduled caste, scheduled tribe, then SC/ST backward district, then backward district rural and urban, and the number of girls per thousand boys. For scheduled caste it is 940, scheduled tribe is 970, And for non-SGST it is 950. Backward district 950 non-level to that. These are the given data for the different sections. And question says you to represent this data in the form of a bar graph. And in the classroom, discuss what conclusion can be arrived at from the graph. So looking at the graph, you have to write what conclusion have been arrived. So you can construct your bar graph by representing the sections on the x-axis and the number of girls per thousand boys on y-axis. So we will take up the x-axis as the section and y-axis as the number of girls per thousand boys. The graph of the information given above can be constructed by choosing an appropriate scale. So we have chosen appropriate scales. 1 unit is equal to 100 girls for y-axis. So looking at the given data, you can construct your bar graph in the form of like this. So in the y-axis, we have chosen the number of girls per thousand boys, and in the x-axis we have chosen the section of the society. So the scale will be 1 unit equal to 100 girls per thousand boys. So SD has 900. So the table says the number of girls is for SD is 940. So we are going to construct the rectangle of the SD that is 940 like this. Similarly, we can construct the bar of those sections looking at the given data. So SGSD, non-SGSD, backward district, like this, rural and urban, we can construct the bar of those section. Your bar graph should look like this, and the bar should be of uniform width. As you can see, there are gaps between the bars. This is a simple bar graph. And for the second part of the question, see here all the rectangle bars are of the same length and have equal spacing in between them. So this should be kept in mind while drawing your bar graph. So second part of the question you can answer. It can be observed that the maximum number of girls per thousand boys, there is 970 for SD. SD has the maximum number of girls per thousand boys. As you can see from the graph, this SD has the longest bar. So SD has the maximum number of girls per thousand boys, and the minimum number of girls per thousand boys there is 900. There is for urban. Also, the number of girls per thousand boys is greater in rural areas than there in urban areas. Backward district and then in non-backward district SCSD and then in the non-SCSD. Next, exercise 14.3, question number 6. The following table gives the distribution of students of two sections according to the mark obtained by them. It represents the marks of the students of both the sections on the same graph by two frequency polygons. From the two frequency polygons, compare the performance of the two sections. So these are the marks obtained by section A, and these are the marks obtained by section B. So the marks ranges from there is the class interval is 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. So in between 0 to 10, there are 3 students who got marks between 0 to 10. So for section A and section B, these are the different marks obtained by the students. So we are going to prepare a frequency polygon of these two sections and compare the performance of these two section, that is of section A and section B. So to draw the frequency polygon of this given data, first we need to find the class mark, that is given by upper class limit plus lower class limit divided by 2. So we need to find the class mark of those given class interval. So let us see. So for section A, the class interval for 0 to 10, the class mark will be 5, that is 0 plus 10 divided by 2 is 5, and the class mark for the class interval 10 to 20 will be 15, that is upper limit 20 plus lower limit 10 divided by 2, 20 plus 10, 30, 30 divided by 2 is 15. Likewise, the class mark for the class interval 20 to 30 will be 25. Like this, you will get a class mark 35, 45. Same here also for the section B, the class mark is here. So to draw the frequency polygon, we take x-axis, we take the class marks on the x-axis and the frequency on y-axis. Our class mark will be on the x-axis and the frequency will be on the y-axis, and the scale will be, the appropriate scale will be 1 unit equal to 3 for y-axis. So on a graph paper, make the x-axis as the marks, that is the frequency, marks class interval, and y-axis as the frequency. So on a graph paper, if you plot those points, you will get the frequency polygon like this. You will get a frequency polygon like this for section A and for section B. So plotting this point, you will get the frequency polygon as shown in this figure. And for the second part of the questions, there is looking at the frequency polygon, the graph of this two sections, section A and section B, it can be observed that the performance of the students of section A is better than the students of section B in terms of good marks. Next, exercise 14.3, question number 8. A random survey of the number of children of various age groups playing in the park was found as follows. So age in years, and the number of children is between 1 to 2, 5, 2 to 3, 3, 3 to 5, 6, 5 to 7, 12. So likewise 15 to 17, 4. Draw a histogram to represent the data above. So we are asked to draw a histogram to represent the given data. As you can see, the class intervals here is 1 to 2, the class size is 1. And the next is 2 to 3, class size is 1, and next 3 to 5, the class size is 2. So the class size is different here, and also here you can see 7 to 10, the class size is 3. So answer to the question number 8. So here it can be observed that the data has class intervals of varying height. The proportion of children per 1 year interval can be calculated as follows. So to draw the histogram, we are going to make the class size of uniform white. So first we select the minimum class white, that is 1, and make it equivalent to the class size 1. So the class interval 1 to 2, frequency is 5, width of the class is 1. So the length of the rectangle will be 5 into 1 divided by 1 equal to 5. And for the class interval 3 to 5, the width of the class is 2. So to make it equivalent to the class width 1, we first multiply the frequency 6 by 1 divided by the width of the class, that is 2, which gives us 3. Likewise, for the class interval 5 to 7, we make the length of the rectangle equivalent to the proportional to the class size 1. So frequency 12 multiplied by 1 divided by the width of the class, that is 2, which gives us 6. And likewise for the class interval 10 to 15, as you can see, to make it proportional, we first multiply the frequency by 1, which is the minimum class size, divided by 5, that is the width of the rectangle. So 10 into 1 divided by 5 gives us 2. Likewise for the class interval 15 to 17 also, the length of the rectangle will be equivalent to 2. After calculating this length of the rectangle, we are going to draw the histogram. So taking the age of the children on x-axis and proportion of children per 1 year interval on y-axis, the histogram can be drawn as follows. So on y-axis, we take the proportion of children per 1 year interval, and on x-axis, we take the age of the children. And we'll draw those rectangle, length of the rectangle of the corresponding class interval, and we got a histogram like this. So your histogram should look like this. Next, exercise 14.4, question number 2. In a mathematics test given to 15 students, the following marks out of 100 are recorded. So these are the marks obtained by 15 students following a mathematics test. The mark is out of 100. So you are to find the mean, median, and the mode of this data. So to find the mean of the data, that is the average of the data, first we sum of all the observation, that is we find the sum of all this observation, sum of all these marks divided by the total number of observation. The total number of observation is 15, as there are 15 students. So we find the sum of all this mark, and we got it 822 divided by the total number of observation divided by 15. 822 divided by 15 equal to 54.8. So the mean of the data is 54.8. Next, to find the median of the given data, we first arrange the data in ascending order. So arranging the scores obtained by the 15 students in ascending order, we got like this. So as the number of observation is 15, which is odd, therefore the median of the data will be given by 15 plus 1 divided by 2. That is, the 8th observation will be our median. So after 8th observation, we found out that from this data, which is arranged in ascending order, the 8th observation is 52. So the median of the data will be 52. And also the mode of the, to find the mode of the given data, we observe that the 52 occurs the most. It is 52 occurs 3 times comparing to the other numbers. So the mode of the given data will also be 52.